Uh, Dear participants, good evening to all. I welcome you for the second day of the ATAL online 6-day FDP. Today is the second day. Third session will be handled by Dr. S. Jeeva. The session topic is deep learning and neural networks. At the outset, I want to welcome Dr. S. Jeeva, Associate Professor from Dayananda Sagar University, for accepting our invitation and be a resource person for this session. Dr. S. Jeeva is an accomplished academician and researcher with over a decade of experience in computer science, specializing in video analytics, artificial intelligence, and IoT based solution. He holds a PhD degree in computing sciences and engineering from VIT University, Chennai, where his research focused on motion pedestrian detection in video surveillance system. He also completed a postdoctoral fellowship at University Malaysian Kelantan, Malaysia, in advancing work on liver tumor segmentation using visual transformers. Dr. Jeeva has also served in various teaching roles, including assistant professor position at Jain University, Bangalore, SRM Institute of Science and Technology, Chennai, Brilliant Institute of Engineering and Technology, Hyderabad, VIT Chennai, and Anna University, Trivandrum. His academic contributions are marked by innovation in digital teaching tools and mentorship. His students have secured global internship and launched startups under his guidance. He is a prolific researcher with over 30 Scopus and SCI Index journal publication and book chapters, contributing significantly in the domain like healthcare, AI, smart agriculture, cybersecurity, and cognitive IoT. Dr. Jeeva holds multiple Indian patents, including design for healthcare and surveillance devices. He has led consultancy projects with Samsung Prism, SRM SIAC, and actively participated in research collaboration, including a funded visit to Zhejiang, Liverpool University, China. His expertise spans programming, which includes C, Python, Java, and open source tool, machine learning platforms, and IoT systems. He is a reviewer of reputed journals like Computational Intelligence and Wireless Network. And Dr. Jeeva is also affiliated with various professional bodies such as IAENG, IFERP, and CSTA. He is dedicated to continuous learning, and he has completed several certification courses and training in AI, robotics, and IoT. His career reflects a balanced blend of academic rigor, innovative research, industry collaboration, and student empowerment. On behalf of our Department of ECE, Government College of Engineering, Salem, we welcome Dr. S. Jeeva for this session. Welcome you, sir, for this session. Please carry on with the session.
Yeah. Thank you, Manipal. It's very detailed introduction about me. Thank you for that.
Yeah, thank you. You able to share the screen, Jeeva? I mean,
actually, make it. Can you make it as a co-host so that I can?
Yeah. 1 second. I made it. So I already co-host only.
Okay.
Yeah. Try to share.
Yeah, sure.
Yeah.
Yeah. Are you able to use?
Yes, it's visible, Jeeva. Yes, please.
Okay.
Yeah. Thank you.
Okay. Okay. So, Manipal sir, is this a presentation mode?
Yeah, it's presentation mode. Yeah.
Yeah.
Yes.
Yeah. So, good evening, everyone. Myself, Jeeva, already Manipal gave a detailed introduction about me, the qualifications and the recent research which I carried out and all those things. So, don't want to be directly we go into the topic. So today I take the topic is deep learning and neural network. So people are aware what is deep learning. I mean, how what is the importance of deep learning, and where and how it's be useful for the making of application and the product. So deep learning is be everywhere in the technological world. So it's supposed to be on internet. If you take an internet and cloud, image classification, speech recognition, language translation, and language processing, sentimental analysis, and recommendation system. So for all varieties of on internet source, I mean internet applications, we are supposed to use a deep learning is be part to make that into more interactive and user-friendly kind of applications. Like if you take image classification, if we in Google we have a image search, so if you're giving image, from the image it's supposed to be extract the features, and it's supposed to be get the information, and that through the information it will supposed to get the relevant output on the image search. Like on speech recognition, if you are giving some input to the on internet, on a web browser, it's supposed to be recognized what kind of language it be, and what kind of information is be shared by that through the audio. So it is easy for the people to read and understand the content of the different languages. And language translation, if you go for abroad somewhere, the translators are supposed to helpful to communicate the people who are by other end. So likewise, and sentimental analysis system supposed to be learned by itself, and it would be Alexa, or likewise a lot of tools which will be available in the market, which is supposed to be understand the people mindset and the behaviors through which it's supposed to react to play music or videos or stories like that. So and recommendation system, it's supposed to be like if you are searching something on the Google search, it automatically we can get a recommendation of some ads. Like if you are searching some product, so relevant to that product, what are the product which is available in the market, those kind of recommendations we're getting as an ad or something. So is the application use case on internet. So on medical and biological domain, so detecting of cancer cells and getting precision of that direction is be with the help of deep learning is be more, and diabetic grading. So through the data set, I mean, through the information getting from the user, we system supposed to be detect classify what kind of data diabetics which is the patients be having, and to overcome that what kind of steps need to be done. So all the guidelines which is supposed to be giving to the patient through the deep learning and drug discovery and media and entertainment, on media and entertainment, video captioning and video search and real-time translation. So if you are taking part in the public meeting with different varieties of audience be sitting on that meeting that time, online real-time translations be helpful to translate what the things which is be communicating by the speaker with the different languages. And if you are watching a movie, so video captioning is supposed to be helpful to get what the content is be delivered from the video movie. And security and defense, the face detection and video surveillance and satellite imagery, because at satellite imagery we are getting large I mean a huge amount of information will be there in that satellite image. So it is quite difficult to process those image with the human eye or the human. So deep learning play a vital role on the satellite image, because the satellite image having a very huge information compared to the other images. And autonomous vehicle, so pedestrian detection and land tracking and recognition of traffic lights. So for that, deep learning play a vital role to detect those kind of for making of those applications to get a better accuracy, because we have nowadays everywhere we having a data. So the data has be collected through the sensors, and it needs to be after collecting the data, we need a system to process those data, because if you are in early stage early time, even though that time also we have data, but collecting of data and the processing of data is to be very hard. So we don't have any algorithm or computation method to do that operations. But now we have computation method, and we have computation algorithms, and we have high-end processing devices, and we have storage capacity, all those things we have. So with that all benefits, we are creating an application which is be helpful to the human to reduce the effort. So this is a way they are convincing deep learning is be everywhere. So before going to the topic, first we need to know how the machine learning works, so that we are supposed to be understood how the deep learning, because machine learning is deep learning is a subset of machine learning. So without knowing of machine learning, it's quite difficult to understand what is meant by deep learning, how the deep learning is be processed. Okay, so for that, if you take any input image, so machine learning is supposed to be, if you give feed any input image to the machine learning, it's supposed to be get the output of that, what kind of image that is be either bike or motorcycle or car or human or whatever. So it needs to be defined, describe what class of that, what class belongs to that object. So for that, we are having some uh, processing mechanism to learn the system to understand what kind of object that is. Okay, so for that, but if it is a text image, it's be easy, we can easily classify that text belongs to which category. But if it is an image, it's quite difficult by the system to classify that image belongs to which category, because by as a human, I supposed to be, while seeing that image, I supposed to be understand that it's be a motorcycle. But for a system perspective, the image supposed to be like this. If you take the small portion, the for the small portion, the image is be represented like this matrix. So from this matrix, it's quite difficult for as a human, it's quite difficult to understand what's that values, what's that object belongs to. So with that values, how the system supposed to be identified that is belongs to which category, which class. So and moreover, throughout the image, it has plenty of values to be plotted to get the image. So with that, it's quite difficult to understand what it's quite difficult to process and extract the information. So to overcome that, the machine learning play a role. Learning algorithms are play a role to learn and identify the object belongs to which category or which class. Okay, so here they are representing, they are taking features as like the pixel values of the particular locations. So if you're taking the image, if you are considering the image, the a cross mark, wherever this be marked as a cross mark, that is be feature which is be taken for the learning for the algorithm. Okay, so if you're taking this and this as a feature, it's quite difficult because the red color over here and then black color over here is be resembles most of the object having the feature as a part of the image. Okay, if you take it here, here also be black colors be there, and here also the black colors is there. So here in the car also we can able to have the feature be black and red. Okay, so it's quite difficult to understand with the limited features, it's quite difficult to understand the object belongs to which class. Okay, so and even though if you are putting a efficient algorithm to that particular with a minimal feature, it's quite difficult to understand the feature belongs to which class. Okay, so if you are adding multiple features with as an image, pixel values as a for the learning algorithm, that time also is be quite difficult that the object belongs to either car or non-car or positive class or negative class is quite difficult to recognize. So to overcome that issue, we are creating a feature as a group of pixel values. So here we are taking a feature be represented as the handbar and bike. So wherever these features be matching with the training test data set, so it is supposed to be recognized that it be a non-car or car. Okay, so because the handbar and the bike feature supposed to be there only for a motorcycle, so it is not supposed to be there for the car or the human or whatever. or other negative classes, we're not supposed to be have those features. So we need to be find the premium feature which is be easy to identify the mission to be recognized that the object belongs to that particular class. Okay, so for that we need to be identify the features of the object, and then those features we need to be give to the learning algorithm. The learning algorithms be trained and making of the mathematical model for that training. And then whenever if you are giving test image, that time is supposed to be processed with that mathematical model, and it's supposed to be classify the object belongs to which class it belongs to. Okay, so for that it needs a test and a training images to do the process, and also you need to give the with the help of human intervention. We need to be identify which is the optimal feature which is be used to identify the class. Okay, or else it's quite difficult to identify by the system. So with the help of the human intervention, humans supposed to be identify which are the objects be prime object prime features for that particular object. Here we are how we are considered as a handbar and wheel, like that. If you are taking a human, he's supposed to be having a head and hands and leg, then it's be considered as a human. Like that, we need to find what are the what are the prime features be there for the particular object recognition or object detection. So based on that, we are supposed to be trained the model, and we are supposed to test with the test images, so that the system supposed to identify that object, and it will be giving the exact result. So that's the process of the machine learning. But if you're coming for a feature extraction, we have there'll be a plenty of algorithms be there for extracting the features from the image. So shift, spin image, histogram of gradient, rift and texture, and gradient log histogram. So these are the different algorithms which will be there for extracting the features from the image. So histogram of gradient is supposed to be identify the texture of the gradient value of the human. So wherever it's supposed to having this texture, it's supposed to be identified and be fixed as a feature for that application. The remaining part, which is be marked over the remaining region, it least constant. I mean, least interest over here. The region is apart from that the texture. So the disadvantages, like we are supposed to lose a lot of information because we are supposed to be take only this texture alone, and remaining parts are not supposed to be used. And even though some useful information over there, we're not supposed to be take consideration for the process. So that's the disadvantage over the machine learning algorithm, traditional machine learning algorithms, while extracting the features from the image. So to work on those issues, we are going for deep learning technique. So on deep learning, each and every pixel as a feature. First of all, here we are taking feature as the handbar or bike, like that. We are taking feature, and sometimes we are taking some algorithms, some application. We taking features as pixel values, and even though if you are taking a text analytics, if you're taking a database of students for particular application, we are supposed to extract some features alone for that application. We're not supposed to use all application for all features for that application, because if you're taking all the application, then automatically it's be time consuming. It needs more computation power. Like that, a lot of difficulties be there on the machine learning. So, but on deep learning perspective, whatever the data which is there in that particular data set be all be considered as a feature for that application. If you take a image of a bike, motorcycle, so each and every pixel on that image be considered as a feature for that application, and it's supposed to be processed with different mask values, through which they are supposed to get a lot of it is supposed to be extend the data set with a wide understanding of the image. Okay, so for that they are using different weights and different mask or different kernels supposed to be used to create a multiple images from the image, so that it is supposed to have deep understanding of the image. With even though if you're turning head, lightning changes, so all supposed to be affect while on the training. on the traditional machine learning. But if you go for deep learning, if a lightning changes, if it's changing ahead, that are not supposed to be affects much more on the deep learning algorithm, because it's supposed to be while with the help of different kernels, it's supposed to be take each and every changes on the face are supposed to be recorded, and it generates the image for that, and it will be trained for the all possibilities of the samples, so that it's easy for the system to identify or recognize, and the accuracy level of the product will be very high while if you are using deep learning. But machine learning, whatever training data set sample which you are giving, if you are giving 100 samples, through 100 samples only is supposed to be trained. It's not supposed to go extend the samples. But in deep learning, if you are giving 100 samples, it's supposed to be multiple 100 times, 1,000 times, and 10,000 times based on the layers of network which you are going to use for the application. It will be extend much more, and through which the sample, through that sample, it's supposed to be do the process. So that if you are, if already we know that if your number of samples be high, obviously we will get more accuracy. So that's the reason mostly the research they will not supposed to be compare deep learning algorithms to the traditional machine learning algorithms. The traditional machine learning algorithms go with a separate track, and deep learning algorithms which is supposed to go with separate track. They will not compare both it together, because the training samples of the deep learning will be very huge, but the training sample of a traditional machine learning algorithms be the weightage of the training samples be different. So with the different training samples, we're not supposed to compare the efficiency of an algorithm. So they will not supposed to compare. If you are going for any traditional machine learning algorithm, they will supposed to be compared with the traditional machine learning algorithms. And if you are developing, I mean, giving novelty on deep learning, they are supposed to be show compared with the other deep learning algorithms only. They're not supposed to be cross verification. They're not supposed to be used for the validation or comparison. So this is the advantage of deep learning and why we need to go for deep learning. So deep learning is a subset of machine learning algorithm, which sorry. Sorry. So deep learning is a subset of machine learning that uses a mathematical function to map the input and output. So if you take any machine learning algorithm, if you take any machine learning algorithm, deep learning is a subset of machine learning. So each and every layer, it has some mathematical functions to bridge the input and output from the input to the output communications. These functions are exactly not redundant information or a pattern from the data that which enables them the form of relationship between input and output. If you're taking, if you're, for example, if you are taking this input input values x and y, x1, x2, x3, different input, and this is the nodes of the deep learning. So each and every node, they have unique operations uh, based on the kernels. We are supposed to be do the unique operations, so that the information which you are extracting from the node is not supposed to be redundant. Because here, if you are using kernel of for example, the kernel is be 1 0 like this, here it be a different kernel 0 1. This is an example kernel. I'm telling you, this is an example, some exam like that. It'll be a different kernel. Likewise, for how many layers which you are creating, I mean, how many kernels which you are creating. So each and every kernels be not be repeated. So it's be different, so that the image be transformed to different forms. So we are getting multiple samples from the given image. This we call as a learning, and the process of learning we claim as a training. So if you are getting more training samples with help of deep learning. So deep learning is not be invented invented recently. It's be in 1980 itself we are having the term called deep learning, but that time we don't have that much computational power, and we don't have that much samples, and we don't have storage capacity, and all those because of those all limitations. Even though it is be 1980, it be came, but we are not used deep learning at those days. But because of now we have GPUs, TPUs, and NPUs. With the help of those things, we are capable to execute a huge amount of data, and we can able to store those data and process the data. So with all those benefits, now deep learning play a vital role for all the applications. But those days, it's quite difficult to do those. I'm getting those features. So that time it's quite difficult to do the uh, processing of the deep learning. So it's not be able at that time. But now almost most of the applications supposed to be working on the basis of deep learning concepts. And so deep learning, modern deep learning models uses the artificial neural network or simple neural network to extract the information. So which means the deep learning models, through the neural network, it's supposed to extract the information from the image and store it in the deep learning model. Okay, like deep learning is nothing but getting more information about the data. So if you're considering this slide, if you are giving machine learning algorithms, it's supposed to be identify only the text which is be there in the slide. It's not supposed to least bother about the other information which is be hold in the slide. Okay, if you are giving deep learning, it's supposed to be understand what's the font of the slide, what's the color which you used, what's the font size of the text, what's the background which you are using. So all be a part of the information which is be stored on the deep learning. So that's why we are getting more information to process the data for their applications. Okay, so this is the advantage of deep learning to extract complete information about the data. So and neural network that is be happen through the neural network. So it's not the deep learning not supposed to be play as a individual. With the help of neural network, is supposed to extract those information and keep that is be a deep learned data. And these neural networks made up of simple mathematical. So each every neurons which is there in the neural network having own mathematical functions or kernels to do the extracting the information from the data and make arranged it as a layers of the network. So that we are supposed to be having a network with the complete information about the data as an information. And moreover, another that is a black box method. I mean, this is a black box. So what are information which is be there in the deep learning or the mechanism or architecture which we are having, which not supposed we not supposed to be get into we're not supposed to view. We can able to get the output. We giving input and we are getting output, but in between, what are the operations which is be done on that backend, which is quite difficult to understand and quite difficult to view. But nowadays we have some AI tool on for simple applications. We can able to get the black box be white box be modified because in the computer science we are not supposed to all the time we are not supposed to be tell as a black box. After some years and some updations or updates, sometimes it's supposed to be reach to white box because that advancement of the technology. And still for complex application, complex network architecture is be a black box. For simple one layer, two layer network, we can able to get what kind of operations be performing from one layer to another layer, and each every layer, what the kind of what the mathematical functions be there, how with the mathematical function, how the data be modified from the data to information, how through the information, how the decisions be taken, how the activation functions be activating the nodes. So all supposed to be understand with the latest AI support, and we can able to visualize those things. And with the help of the deep learning approach, artificial intelligence, we can, if a combination of hardware and software, we can able to solve the tasks which is be required human intelligence. Whatever human intelligence is required, with the help of the deep learning and the artificial intelligence, we can able to get into the to solve that application. Because some, if you are taking any burner or underwater surveillance, it's quite difficult to human to go there and get the information from the underwater undersea. So those areas, if you are deploy, if you send the robot, and robot supposed to go there, and they get deployed and extract the informations, and it is be transferred to the cloud and do the analytics. So wherever the human is quite difficult to handle or extract the information and data, those locations we can able to send the robots or sensors to over there, and we can get the informations, and based on the sensor values, we are supposed to be act accordingly. Because sensors is the one which generating huge data from the environment. So and at the same time, the deep learning needs more data. With the help of these two combinations, we are getting more effective results. So on deep learning, as you know, is a part of artificial intelligence. So it is a technique which enables the machine to mimic the human behavior. So for if you want to mimic the human behaviors, we need to be feed more information to the system, so that system supposed to be analyze and understand and react for the environment. So for that, we need more information that supposed to be get through the deep learning. And machine learning is a subset of AI technique, which uses a statistical method to enable the machine to improve the with experience. So experience is nothing but the training which we are giving, and most of the algorithms supposed to be work on the basis of statistical method. So statisticals play a vital role on the machine learning algorithms, and very few. I mean, there will be very few mathematical model which is be there on the machine learning algorithm supposed to be using. So mostly we are supposed to go with the line equation and circle equation and distance method. So these are three basic mathematical models which we used for most of the machine learning algorithms. With that, we can able to, and after that we go for probability distributions and normalization like that at the be there. But with the help of statistical method models, we can easily derive any machine learning algorithm for an application. And deep learning is a subset of machine learning which is used to compute the multi-layer neural network as feasible. So multi-layer neural network, which they're mentioning as feasible instance, because we can able to create n number of layers on the network. So if you are increasing n number of layers, so that much competition is being needed for the doing the process. If you are taking a simple application and if you are giving more layers, it's unnecessary waste of competition which is be getting from the system. So based on the application, based on the severity of complexity in the data, we need to be fix the layers. Sometimes if you are go for a face detection or face human recognition, sometimes we are supposed to be recognized with 4 layers, because if you take a human face recognition on face, there be a if we can enable multiple features from the face, but with the limited features like eye, nose and mouth. With these minimal features, we can able to identify that is the face, and the face belongs to which class. I mean, which person. So, so for that, with the 3-layer network itself, we can able to detect that be a human. It need not to be a 20 or 40 layer network. Okay, if you are using 40 layer network for that recognition of a face, this is unnecessary burden given to the system to recognize, and it takes more time to do the analytics and the computer for the training. Okay, so you need to be identify the application and how complexity, how much complexity is there in the data set, and for getting the data to the application. So based on that, we need to be find how many layers be required for that application. So this is how neurons supposed to be perform the operation. So X is the input, and the input supposed to be multiple with the weight values. So weight in the form of the either it be a single value or the kernel values. A kernel instance, the group of the matrix is in the form of matrix. So either it be a single value like 9 or something, whatever the based on the calculation. And the if you are going for image, that time it will be a matrix, and it's up in the image. The input value is supposed to be multiple with the weights and the bias value. So based on that, the value which we are computing over here, it's supposed to be compared with the threshold value. So based on the threshold value, comparison with the threshold value, it's supposed to be activate which neuron supposed to be activated, which node is supposed to be activated in the network. So that's supposed to be carried out by a activation function. So after getting the value over here, it's supposed to be do some comparison based on the algorithm which you're using over on the activation function. It's supposed to be classify that the value which you're getting from the particular neuron goes to which class or which node. So that's supposed to be, so that node alone be activated. Remaining nodes are be deactivated or disabled. Okay. So to find the which node need to be activated, that's supposed to be identified through the activation function. So these are some listed activation functions which is there in the deep learning. Linear, ReLU, softmax, like that. There'll be a lot of activation functions be there. Most of recent deep learning methods, they are supposed to use ReLU and softmax, which is be used for the activation function of the neurons. So on neurons perspective on deep learning is to motivate two ideas. So how the human behavior proves that is be possible uh, to get the intelligence. So the based on that, we are supposed to do the reverse engineering concepts. So we are supposed to know the output and then the input. So through the output, how it's supposed to be get the information, and for that, what kind of mechanisms be applied to get the training samples. So like that, we are doing the reverse engineering process. And after that, another perspective, the working of human brain and the principle underlying intelligence is to build a mathematical model through the scientific questions. So fundamental scientific, because for every neuron, it needs some mathematical model. So to train or getting data from the data to information, it needs some mathematical model that supposed to be have some valid some valid some valid reason why we are giving that mathematical model to get to be placed on that neuron. Otherwise, if you are blindly put some mathematical equations on the neurons and doing the training is we are not supposed to get any information from the information which you're getting from the data is useless. Okay, so what are the mathematical model which you deploy on the neurons that have some scientific having some scientific questions or scientific answers for that mathematical model, so that it's supposed to be have some value with that the neuron holes are getting information from the data through the neuron have some meaning. Without that, it's quite difficult. Even though if you are doing the all the multi-layer neural network, we're not supposed to get appropriate results. So far, all the research is supposed to be happen on the people. They are supposed to create a neural network, and they're getting a fully connected layer. From the fully connected layer, they're getting different samples of the input data, and after that, with the help of traditional machine learning algorithms, they used to the analytics. But very few people only playing a role on checking or modifying the neurons. So while modifying the neurons, that leads uh, if you are removing a neuron or modifying a neuron, that leads to may or may not may or maybe you can get better accuracy. So but the very few research be happen on the neuron level, but a lot of research be happening on the activation function, and then after they are using an ensemble approach, like getting training samples from the deep learning, and then they use go for the machine learning algorithms to do the classification or recognition. So comparison of deep learning and the machine learning. So generally, the machine learning is alternate term to shallow learning. Is effective for some smaller data. So deep learning and machine learning, whatever data, I mean, it's supposed more effective on the smaller data set. But if you go for huge data set, is quite difficult on the machine learning, because the mathematical uh, background on the machine learning is be more having more complexity, so it needs more computation power on the system. So processing of bigger data is quite difficult on the machine learning. But on the deep learning, the mathematical model which is be derived on the each and every neurons is be having very light weightage mathematical models. So is be compare more comparatively from the machine learning to the deep learning. Machine learning having a complex mathematical models, and deep learning is be each and every neurons having light weighted mathematical models which do the process very easier, so that and because of the help of the parallel processing and other stuffs, we can easily execute the deep learning algorithms compared to the machine learning. So that's the reason their machine has very less data set. It'd be fine for more data sets, not be fine on the machine learning. And deep learning be more powerful for a large data set, and it learn complex pattern of from the data, because how it's supposed to be understand the complex pattern of the data instance, because with the help of the neurons, we are each and every input supposed to be sent to multiple neurons and as a layer on the hidden layers. So each and every neuron is supposed to do as own mathematical function. With the help of own mathematical function, it's supposed to extract information from the data, so that even though the data having a complex patterns, is quite easy from by the deep learning to extract information from the complex patterns. But on a traditional machine learning, if it is a complex pattern, it's quite difficult to extract or extract information uh, from the data. For example, if the data is like let us consider this is the data of one class. This is the data of another class. If it is like this cluster, it's quite difficult to classify these two classes data. There is a way on the machine learning to classify this kind of data, but if a data set is be huge, then it's be quite difficult to classify this kind of clusters, because all both classes be equally, collapse more complexly. So it's quite classify those data. So that if it is a complex, that's the reason. If it is a complex pattern, it's quite difficult to do perform on the machine learning. But that is a way to handle those data. I mean, handle this kind of data on the machine learning. But it's bit too hard. It requires more computation power. But on the deep learning, it's be easy for the deep learning to handle this kind of data. Even if you are using machine learning algorithms, you need to be project the data. One class need to be projected with some location, so that it's supposed to move to the class one from the class two. So the from that we can able to classify. But it's BTDS task, and it needs additional computation power to the system to do the process. So, but those things not required on the deep learning. Is if you are even if it's this complex pattern, if you directly give data to the network supposed to be take care everything, and it gives the output. That's why deep learning is being more easiest. And even though, and also if you're giving input and do the all kind of analytics, training, and pre-processing training, and all those things be done in this as a black box, and finally we get the output. So we least bother about the operation which will be there in which will be performed inside. So if you give it that input, and you will get the output as immediately. So the complex patterns suppose data is supposed to be get from the text corpuses, social media activities. So those kind of applications, we are supposed to having complex patterns, because on social media is be unstructured data. We are not supposed to be extract what kind of data which we are getting from the source. So it's hard to do analytics on the social media data, so that those kind of data is easy on the deep learning. And also generate the new data samples and find the anomalies on the machine learning algorithms, and which is be human eye miss. So even though what from the naked human eye, we're not supposed to be identify what's there in that, through the deep learning is be quite easy uh, to understand the data, to convert into the information. And also deep learning is supposed to be generating the multiple samples from the given input sample, so that we are getting a huge number of input samples to do the process. Actually deep learning play, why developed meant for the medical images, because on medical image usually we are not supposed to get data input data, images, because getting a 5 images is quite difficult on the medical domain. So to handle that issue, they are start using of deep learning. From that, the performance of that deep learning on the medical image will be huge. They understood that, then they went. They make that into the other applications. But actual the use case of the deep learning is be started with the medical image, because that's the reason it be. If you take any text analytics or other applications, we are having huge data. So if you have huge data, then through the machine learning algorithms, we are supposed to, even though if we have, need a high computation power, but it's be okay to do the analytics to get the information or get the output. But on medical image, we are having very less data, which is be a count of 5 or 10, as be countable number of samples. So with that sample, it's quite difficult to do the analytics, because with the less samples, if you train the data, train the image, and if you test the image, we are not supposed to get them that much accuracy. So it leads to failure of the model. So they need multiple samples for that. with the help of human intervention, they are supposed to be generate the samples by changing the lighting and changing the transforming the image, mirroring the image like that. They manually they did those things, and they increase the samples for on that image on the domain and giving to the algorithm. But it's not that much easy task while doing it in the manual. So to overcome those issue, they start using the deep learning. So deep learning is supposed to be helpful to increase the samples and do the analytics. This is a process of deep learning and machine learning. If you are in machine learning, if you are giving input, it's supposed to be extract the feature. So feature extraction is supposed to be either human need to be find the features, what are the features be useful for that application, and those features they need to be used for, they need to be sent to the application to do the analytics, or else with the help of any feature selection algorithms, they need to be run the feature selection algorithms through which they can identify the features, and they need to be give for the classification and then we are getting the output. But on deep learning, if you are giving input, the deep learning is supposed to be take care of everything. It's supposed to extract the features and do the it's supposed to do the pre-processing, extract the features and do the classifications, and then we'll get the output. One more disadvantage over here. What are the input which you are getting from the source? You need to be do the pre-processing, because we are supposed to be sent directly as an input image to the processing next level, because it's having some noise and some uh, all the images not having the same size or something. Okay, but on deep learning, each and every values or data or pixel be act as a features. So only we need to be do the cropping. After the cropping, we directly send that image to the process. So the network supposed to be take care everything, and for extraction features and do the analytics and perform the classification to get the output. But here on machine learning, we need to be do separately. So why we need to go for deep learning due to the advancement of algorithms? Because there'll be a lot of research be happening on the deep learning, and every decades we are getting updated deep learning algorithms are there in the market for, I mean, in the literature with good accuracy with different applications. So previously we are supposed to use CNN, RNN algorithms for do the analytics, but now we are in transformer. After transformer, the VIT visual transformers, then encoding, autoencoder, decoder, then LSTM, and likewise the advancement is of algorithms be there. A lot of research be happening on the deep learning to get to this. I mean, they are generalizing the network for getting, I mean, for single network to do the operation, but so far is not be generalized for each and every application. We need to be create a own network. That network is supposed to be do the process, but future that be chance of getting a common network which is be perform the most supposed to be handle most of the applications. So and now we have a GPU, TPU, and NPU. With the help of that, we are supposed to do the analytics, TensorFlow processing unit, and neural processing unit, like that. Or the processing units are, I mean, computation powers which we have for executing the algorithms, and also the availability of large data sets. So now we have a huge number of data set for the applications which we are taking consideration to make as a product. So with that of the large data training data set and the deep learning, with together we are supposed to get good quality and efficient applications we are getting through the deep learning and the large training samples. So deep learning is expensive compared to the machine learning. Of course, deep learning needs more computation power and then the storage compared to the machine learning. But the only thing, the accuracy. If you go for any medical related application, There, they least bother about the expensives and the computation power and time. They very much bother about the accuracy. So those cases, deep learning play a vital role to get a more accurate result from the data samples. And so on deep learning and machine learning, both are capable of different types of learning, like supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is nothing but the learning that data which is be labeled. So all the features in the data set is supposed to be labeled so that the features belongs to which category. I mean, features belongs to which category, and what the information is be loaded on the particular feature. All supposed to be mentioned on the supervised learning. So the system easily identify all the features, and it's supposed to be classified based on the classes which is be available on the classes. But unsupervised learning is be like unlabeled data is supposed to be get from the social media, because on social media we are supposed to get input like data like sometimes we are getting text input, sometimes we getting video, image, mgo, emotional images, audio images, audio files. So it's quite difficult to create a data set with different categories. So that time that's will climb as a unsupervised learning. And reinforcement learning is be like um, fail and learn. So it's be learned by the system by through the failures. So for all those cases, deep learning and machine learning is supposed to be having some algorithms to do the operations. And usefulness is usually determine the size and the complexity of data. So based on the size and the complexity of data, we are supposed to be go either deep learning or machine learning, because some use cases machine learning is be sufficient to do the process. Some use cases we need to be deploy the deep learning. So based on the use case and the complexity of data, we need to be identify either we need to go for a machine learning or deep learning. So quick summarize what we so far we discussed. After that, we are supposed to look it on what are the different varieties of deep learning algorithms will be there. So machine learning requires data pre-processing and involves human intervention to find the features of the data. But deep learning, neural network and deep learning is capable to extract the features by its own without a human intervention, because with the help of the neurons, it's supposed to extract the features from the data. And deep learning can process unstructured data. So unsupervised data also is supposed to be performed. And finding and extracting the information or patterns to represent the entire data set. So is easy on the deep learning, but finding a patterns on the data is quite difficult on the machine learning, because on machine learning it's supposed to be we need to be convert the data into data points, and after that the data points need to be plotted in the graph. From that only we are supposed to understand what kind of patterns be there in the data points, how we are supposed to handle those patterns to extract the information from the data points. So it's quite it has a lot of tedious tasks to be behind for identifying algorithm and extracting features from the data. So, but in deep learning, it's not be like that. Whatever, even though it's be complex patterns, we directly give it into the deep learning network. We supposed to get the data. And deep learning is more expensive and time consuming. Of course, it's be more expensive and time consuming because of the network which you are using. If you are using 40 layers or 60 or 120 layers, so sometimes it needs to run one day or 1 week or something. There'll be some network which is be supposed to take 1 week or 1 month. So based on the number of layers, number of epochs which you're using on the iteration, epoch is nothing but the iteration. So how much epoch and how many layers which you are having on the deep learning neural network, based on that, it takes more consumption of a time. If you're having less epoch and which is less iteration and less layer, then it will be executing in hour or 2 hours or half an hour something. But if you are going for but if you are having less epoch and less layer, the accuracy will be very less. If you are go for uh, more high epoch and high value of epoch and number of layers be high, then it's be a overfitting. If you use less layers and less epoch, it leads to underfitting problem. And if you are giving more, then is go for more fitting problem. So we need to find how much layer is be required for the application and how much iteration is needed for that application. So then only that need to be identified, and based on that, if you are developing application, is easy to make uh, the application more effectively, and we get the results which you're getting from the applications be more accurate. So deep learning neural networks have multiple layers be connected through artificial neurons. So it's not a natural neurons. We are creating a neurons on the network to do the operations. Either we climb as a neuron or annotate as a nodes. If you are go for if you are annotating, if it is a graph, then we are annotating as node. If your biological term, if you want, is be a neuron. So each of these nodes as be as having a simple mathematical functions. So each and every nodes having its own mathematical function. Through the mathematical function, it's supposed to be convert the data into the informations or extracting information, extraction of linear function to perform the extraction and mapping of the information. So with the help of this mathematical function only, the data is be converted to information. So that information is supposed to be check with the threshold values. If the threshold, if it is belongs within the threshold, it is supposed to be active to the particular neuron or particular node. If it is not, if it is, I mean, there will be plenty of neurons be there in that before the activation function. So based on that activation value, it's supposed to be select the particular neuron, and remaining other neurons supposed to be disabled. So that neurons, what the value which is there having in the particular neuron, supposed to go for the further operations. So there will be a three-layer neural network. So basically, it having three layers: input layer, hidden layer, and output layer. So input layer is supposed to be get input, and hidden layers do processing, and output layer we are getting the output. So these are types of neural network. Convolutional neural network, recurrent neural network, and generative adversarial neural network. So these are different varieties of neural network. For based on the applications, we need to be choose which network will be suitable for that application. I mean, based on the application, we need to be choose the network. If you are taking what? If you're taking any image related, computer vision related applications, then we need to go for convolutional neural network. So convolutional neural network do the analytics for medical image and video analytics. Recurrent neural network is supposed to be used for NLP, text analytics, NLP related applications, and text analytics. We go for recurrent neural network. Generative adversarial neural network is supposed to use for both convolution, both text and I mean both image and NLP applications. Because in here generative AI is here generative AI is supposed to use for multiple the samples. If you're having less samples through the generative AI, and generator and discriminator is supposed to be used to generate the samples. So convolutional neural network is shortly we call as a CNN model. So CNN model will be used for the applications relevant to the computer vision application and video and image processing kind of relevant applications. We can use convolutional neural network through which I mean convolutional neural network we can able to do handle 2D image and 3D image. So what kind of images which we are giving, either 2D or 3D, whatever. through the CNN, we can able to handle those data, and through CNN we can extract the features and the patterns of the image. So that's for that only we are using CNN. So because if you have okay, if you take the image as a Zeravi, and for Zeravi image, there be multiple features be there in that image Zeravi, and it be standing on the desert, and uh, over there it be a white color, it be some which is resembles the smoke or something like that. There'll be plenty of information be there. If you are using machine learning algorithms, it's supposed to be get the features of the particular Zeravi and do the analytics. It least bother about the information which is be located on the different parts of the image. Okay, but in deep learning, it's supposed to be take each and every pixel which is be there in the image. So each and every pixel which is be located on the image is be handled and do the process, so that we're not supposed to miss any information from the image. So all the information be recorded on the neural network, and that's supposed to be used for the output. So through the convolution is nothing but there will be a mask, or convolution mask will be there. So the convolution mask supposed to be convoluted on the image, so to extract the information from the image. So image is be data. From after convoluting the mask on the image, we will get the information, and that there'll be a lot of masks to be there on the neural network. So all the masks supposed to be run on the image to extract the information, different varieties of information, and it be loaded on the neural network. Here is be for understanding purpose. They are giving for they taken a single neuron, and they are getting a single region. How it's be supposed to be converting from one layer to the another layer. First is the convolutional network, then max pooling, and flattened layer, and fully connected layer. Through the fully connected layer, we are supposed to be get the output. So if you're taking 10 data set is having 50,000 training image and 10,000 test image, and each it has 10 categories of which categories instance 10 classes of images. Classes like airplane, automobile, bird, cat, bear, dog, frog, horse, ship, truck. They like different classes are there in the data set. So for each class, it be equally distributed on the training dataset, so that only we are supposed to have that balanced dataset, because on the any machine learning algorithm which you are developing, it's supposed to be tested on the balanced dataset. Then only we are supposed to be get the values which you are getting from the as output is be valid. If you are testing with the unbalanced dataset, then it's quite justify the results with the other results. So while taking a dataset for testing the algorithm, we need to be take the balanced dataset, and the dataset is supposed to be balanced dataset and benchmark dataset for that application. Then only we supposed to be test our algorithm to that dataset, and the accuracy which you are getting is be trustable or reliable. So with that samples, it's quite difficult for accuracy of human is be 94 percentage, and k means algorithm is supposed to getting 80 percentage of accuracy, but on deep learning we are supposed to get 95 percentage of accuracy. um, 95, this is traditional CNN model. If you are using a deep uh, neural architecture with multiple layers, that then it will goes about 99% and more. They may be used convolutional neural network with convolutional neural network alone with a less layer, so that the reason maybe they got 95%. So is a step-by-step procedure how data has be processed and it will be converted on each and every layer, how it is be loaded on the deep learning. So it's the input image. Let's consider this is the input image, and this is a kernel. The box which is be mentioned as a kernel is be 3 cross 3 kernel. The kernel will be anything, any kernels which they can use to convolute on the image. For example, if you are using kernel like 0, like this kernel, then this kernel value is supposed to be multiple with the values which will be there in the matrix, and every for this, I mean, for this location we are getting the value of this pixel, and if you are taking and convoluting to next layer, the value this is for this one. Likewise, it needs to be convoluted on the entire image, so that we are supposed algorithm not supposed to miss any information on the image. So it's supposed to be evaluated on convoluted on all the parts of the image. So from the image data, it's be converted into the information which is be loaded on the as a lower layer of the deep learning. So next, after after converted output, we need to be find the max pooling. So max pooling is nothing but it's supposed to be find what the maximum value which is be the converted output. If we take this, one here, the maximum value of this kernel is be 6, and this kernel the maximum value will be 8. Over here, the maximum value is 3. And here, this maximum value is 4. Like that, the max pooling be happening. And we after the max pooling, we need to be. So why we need to be do that max pooling instance? We need to be down the samples, because all the samples we which is having a less value, because these are the information. It's not the data. It's the information. So from the information which is having a most high value, so that information is be sufficient to do the further analytics. So we are doing down sampling through the max pooling. And so after doing the max pooling, then dropout. So dropout supposed to be happen through the activation functions, because through the activation function it has some thresholds. So with the help of the threshold, if this belongs to that particular node, then those nodes supposed to be activated. Remaining nodes are be disabled. Like I said previously, if the y is equal to mx plus, sorry, y is equal to wx plus b, based on that what the value which we are getting, that's supposed to be compared with the activation function. And then if it is belongs to that particular node value here, because each and here some values be there in the each and every nodes, some threshold here is be 2, 4, 10, 12, like that, some values be threshold values be there. So the value which you're getting from this node is be matches with any of the nodes threshold value over here. So those nodes are supposed to be activated, remaining nodes be deactivated. The list was of those nodes. From this node, it start to the analytics. So that's the dropout. And after that, we have a fully connected layer, dense layer. So with that dense layer, we are doing the or getting the output. And why GPU matters on the deep learning instance? Because if you're using CPUs, it takes more computer. I mean, it takes more time on the system. If you take GPU, it will take very less time. So that's be based on the epoch which you are using. Because if you are using more epoch, here they use 200 epoch. So for each epoch, it will take 734 seconds. So just calculated for 20 epoch for a single network, how much time it will take. Okay, for a single layer. Likewise, how many layers which you are having, it need to be run for all the layers. For if you are using GPUs, TPUs and GPUs, NPU, that time considerably it be reduced the time. And as you know, for RNN recurrent neural network is mainly used for NLP kind of applications. So text, audio, analytics, we can go with RNN algorithms. Because RNN, there be a back propagation methods be there through which they can able to back propagate the output to the hidden layer to do the process. And generative AI, it's a generative adversarial neural network. So which it supposed to be perform the unsupervised learning, and it also be handle structured data patterns to use the and generating the new samples for the application. So with the help of generator, and generator supposed to be generate the samples, more samples, and discriminator is supposed to discriminate whether that is belongs to which class. And transformer, so nowadays the traditional the era will be a transformer model. There will be a lot of advancement on the deep learning through the transformer model be achieved. So there will be a lot of algorithms be there in the transformer algorithm. I mean transformer model technique. So VAT, swing transformer, U transformer, U-shape transformer, and encoder, decoder, and likewise there will be plenty of new algorithms be evolving on the current literature. And now next era would be like they are getting data samples from the transformer, and then they that samples be transferred to the machine learning algorithms, traditional machine learning algorithm, for getting more accurate results. So through the transformer, they are getting more samples. So once the samples be multiple, then they go for any traditional machine learning algorithm which is be compatible to execute that much samples to the uh, with the available computation power. So because we are supposed to be because on transformer deep learning model, we are supposed to have huge number of samples for the training. So with that samples, it is quite difficult to do the complex mathematical models. So we need to go for lightweighted models, so that we'll supposed to be expect some reasonable time to get the output. And limitations, so data availability, and deep learning, what are the limitations be there? Since data availability, complexity of the model, lack of global generalization, incapable of multitasking, and hardware difference. These are the limitations which is be there in the deep learning. So data availability, in sense, there will be some applications we don't have sufficient data to do the analytics, especially on medical domain. Because on medical domain, first thing we ethical clearance from the medical practitioner is be very tough. And after getting the ethical clearance, we're not supposed to be publish the data into the public forum, because government not supposed to be allow the country's medical data to the another country. So it's quite difficult to getting a public data set for the application. So data availability on the some applications will be quite hard. So if you don't have data considerable limited data, training a model is quite difficult. So that's a major difficulties which is be there in that deep learning. Even though deep learning is supposed to be generate a huge from the given samples is supposed to be generate more data, but we need a varieties of samples for different cases. If you're detecting human, for a single human, if you are having multiple samples, there is no use how the system supposed to be identify different varieties. I mean, the fatty, thin human, those kind of images is not supposed to be detected. It need all classes. I mean, for the particular class, different varieties of data need to be loaded onto the data set on the deep learning, so that is supposed to be classified. Will get accurate results. So for all varieties of particular application data need to be give as an input to the model, or else it's quite difficult by the system to do the analytics. And the complexity of model. So a simple model leads underfitting. What I said, if you are having a less epoch and less layer on the network, then we go for underfitting problem because the training model which were trained with less epoch and then minimum number of layers, it's not sufficient to do the classifications. So that time we will get an underfitting problem because the algorithm if it work is fine, but because of lack of data and lack of what layers, it's performing not performing well. So it comes under underfitting. If you go for huge number of epochs and a huge number of layers, then it goes for overfitting. So you need to be find how many layers be needed, how many epochs be required for the training. So then only we'll get with minimal computation and the execution time, we'll supposed to get the exact results. And global generalization. So there is no generalized architecture be there in that deep learning. For based on the application, we need to be go for the architecture layers of the architecture in the neural network. So if you are using same architecture to different applications, obviously there be error rate will be high. So it not supposed to be support for that application. So we need to be trained and we need to be make a network for the specialized applications. So then only we are supposed to be get the accurate results. Multitasking. So on deep learning or any machine learning algorithms, you take it's supposed to be do not supposed to be do multitasking. If you are training, if you are doing classifying cat and dog, is supposed to do that alone. It's not supposed to do human men or woman like that. Multi-class classification is supposed to be done, but on the multi-class classification is supposed to be one positive class and multiple negative class be fine. But if you are going for multiple positive class, it's quite difficult on the any machine learning algorithms. So auto dependence. So it since it's be having it needs more mathematical models and multiple layers be there in that deep learning. So it needs more computation. It needs more computation powers like high power computing, like GPUs and TPUs, and now we are using NPU systems for fast and quick processing of data. So if you are using a traditional computation CPUs, it sometimes is supposed to be take more time to execute. Sometimes it's supposed to be crash the processor because of overheating of by the processor. So if we high compression process be happening on the processor, it will get more heated and it will damage the hardware. So and sometimes it will take more time to execute the data applications. So to minimize those things, we need to go for GPU and TPUs. Obviously if you go for GPU and TPUs, the cost of the devices be high. So it's quite difficult the people to use such GPUs and DPUs for making their applications. Now, with the help of cloud services, we can able to renter the GPUs and TPUs and do the process. But still, that it needs additional charges for the analytics. So these are the limitations which is be there for the deep learning, and these are some applications where the deep learning play a role on effective utilization of the applications. Self-driving car. So with the help of deep learning concepts or deep learning algorithms, autonomous cars are be running. So it's supposed to be capture data from multiple sources of sensors and the cameras, and all data be grouped together and do the analytics, and it will be detecting the it will be performing the self-driving car because as I said, deep learning is supposed to be used more computation. I mean, it'll take more time to execute, but that's be only on the training stage. Once the training models be trained and models be generated, then it's be generating a fraction of second to get the while on the giving the test images. So only training time will take more computation power and more time to do the training. So once be trained, then for testing is be done fast. Automatic handwriting generation and a pixel restoration. So in in our mobile we have a AI eraser and a background remover. So all supposed to be applications of pixel restoration. So if you remove the pixels and it be restored with the available pixel which is the around the surroundings. So that's the process which is be used for the AI erasers. If you erase over here, so it's supposed to be filled with the region all around the neighbor. Okay, so if you erase the blue over here, is be removed, and over the region it's supposed to be filled with the blacks pixels. And colorization of black and white images, that's up. So the color, when black and white images or videos supposed to be converted into color videos and images through the deep learning, and deep dreaming and detecting a growth delay of child and democratic predictions and sound addiction and silent removal films, news aggregations and automatic mission translations. So these are the different varieties of applications where the deep learning play a vital role. So it's not be limited over here. There be plenty of applications be there for the deep learning, and now is be ready to do deploy into the hardware level too, because we have a very lightweighted deep learning models with the help of PyTorch and other tools which is available in the as a available software. We can able to deploy the deep learning into the Raspberry Pi level kind of applications. Also a product also we can easily make with the lightweighted deep learning algorithms. The lightweighted softwares also be there, and lightweighted algorithms also there to deploy those into the edge devices. Okay. So this is the ending of my session. I mean, is there any doubt? I hope session.
Yeah, Dr. Jeeva, thank you very much. Okay,
Exactly, I
thank you.
completed.
Yes, on time. Yeah. Okay, thank you, Jeeva, for giving us this wonderful session on neural networks and deep learning. I'm going to unmute the participants. If they have any queries, they can ask. Yeah, the participants can unmute themselves and they can ask the query to the professor. I have a query. While reading your bio, I found that you did a research in IoT, right? Can you shed some light in how your machine learning and IoT, I mean, in what way your IoT and machine learning can work together? One second. It's mute.
So I created application like face recognition based smart lock. So wherever the authenticated persons be enter, when be in front of that camera, it's supposed to be unlocked. So there
Okay.
is no the person during COVID time, they're not supposed to be quite difficult to touch, or doctors they're not supposed to be willing to touch anything. So they need touch-free devices to do the process. So that time, if you go inside in front of the camera, is automatically if it is authenticated person, it automatically open the lock. That is essay is, I mean, the project be completely funded by SRM.
Okay. And there is a question from Kavita Pandian from CSC department. She is asking that which hybrid method is the best? The chat box. Yeah.
The hybrid method, because that's be purely based on that application which you are choosing. If you are taking medical image, we are supposed to go for transform model. Through the transform model, we extract the features, and through the regression, we can do the classifications. Likewise, it's not supposed to be, it's not generic. So it's purely based on the application which you are choosing. And for that application, which is be suitable architecture or a network to extract the features, and which algorithms be suitable there on the literature on the traditional machine learning algorithms. So then only we are supposed to be hybrid. It not be generic.
Okay. Okay. Someone is asking something like, in case of large data set for deep neural network, how to cope up with real-time application? Yeah, that time
See,
is a constraint. Yeah, that's it.
see, it on real-time data set, I mean real-time, once the models be trained, then automatically through the SAM trained model, it's supposed to be do the process. So it's no issue on whether it be a real-time data or stored data. If it is machine learning, then we need to be check it. I mean, on the training only, we need to be there be a time constraint. If you go for testing, that time there is no constraint because the models be actually generated. So with that model only, we are supposed to go for running the application.
Okay. Okay. Thank you, sir. Someone is asking for the PPTs. We will be posting the PPTs in the
Yeah, we'll
WhatsApp group.
share.
Yeah.
Yeah,
Yeah.
yeah,
Yeah.
yeah.
Okay. And someone is asking, Venkatesh Ramchandran is asking, how generative model differs from deep learning?
So generative models, it's supposed to be sorry. So generative model is like generate is a recent model which is be there in the technology. I mean, now only is be generating with the deep learning also be supposed to be create a samples, but the samples which we not supposed to be view. But on generating models, we are supposed to know how the images be generated. I mean, how the generated image we can able to visualize.
Okay.
Because deep learning with the help of kernels, it's supposed to once the image is be given as input, it's supposed to be converted into
Mm.
as a information on the neurons. But generative AI model, it's supposed to be create a multiple images from the
Mm.
given input image.
Okay.
We claim as a deep fake images.
Okay. Okay, sir. So thank you very much. For taking this session. I hope our participants got some valuable insights from your session. Thank you very much.
And thanks for a nice audience. They asked almost everybody listened everything, and thanks for the opportunity. Thank you,
Thank you. Thank you.
Nice.